Alright, so for today's advanced concept presentation, it is going to be a little bit different because we are learning about nuclear chemistry. And since that is not the easiest to do at home, we are going to be learning about how nuclear bombs work. So I'll be making a presentation on the type of nuclear chemistry needed for a nuclear bomb to work. Okay, so first off, atomic bombs are nuclear weapons that use the energetic output of nuclear fission to produce massive explosions. Nuclear fission is a process where the nucleus of an atom is split into two or more smaller nuclei, known as fission products. The fission of heavy elements is an exothermic reaction, and huge amounts of energy are released in the process. Nuclear fission occurs with heavier elements, where the electromagnetic force pushing the nucleus apart dominates the strong nuclear force holding it together. In order to initiate most fission reactions, an atom is bombarded by a neutron to produce an unstable isotope which undergoes fission. When neutrons are released during the fission process, they can initiate a chain reaction of continuous fission which sustains itself. With atomic bombs, these bombs are in contrast to hydrogen bombs, which are both fission and fusion to power their greater explosive potential. So only 2 nuclear weapons have been used in the course of warfare, both by the United States near the end of World War II. Atomic bombs are made up of a fissile element such as uranium that is enriched in the isotope that can sustain a fission nuclear chain reaction. When a free neutron hits the nucleus of a fissile atom like uranium-235, their uranium splits into 2 smaller atoms called fission fragments, plus more neutrons. Fission can be self-sustaining because it produces more neutrons with the speed required to cause new fissions. This creates the chain reaction. The uranium-235 content of weapons-grade uranium is generally greater than 85%. Though inefficient weapons, deemed weapons usable, can be made of 20% enriched uranium, the very first uranium bomb dropped on Hiroshima in 1945 used 64 kilograms of 80% enriched uranium. In fission weapons, a mass of fissile material, either enriched uranium or plutonium, is assembled into a supercritical mass, the amount of material needed to start an exponentially growing nuclear chain reaction. This is accomplished either by shooting one piece of subcritical material into another, termed the gun method, or by compressing a subcritical sphere of material using chemical explosives to many times its original density, called the implosion method. The implosion method is considered more sophisticated than the gun method and only can be used if the fissile material is plutonium. The inherent radioactivity of uranium will then release a neutron, which is bombard another atom of 235 uranium to produce the unstable uranium-236, which undergoes fission, releases further neutrons, and continues the process. The uranium atom can split any one of dozens of different ways as long as the atomic weights add up to 236, uranium plus an extra neutron. The following equation shows one possible split, namely into strontium-95, xenon-139, and 2 neutrons plus energy. The immediate energy released per atom is about 180 million electron volts. Of the energy produced, 93% is the kinetic energy of the charged fission fragments flying away from each other, mutually repelled by the positive charge of their protons. This initial kinetic energy imparts an initial speed of about 12,000 kilometers per second. However, the charged fragment's high electric charge causes many inelastic collisions with nearby nuclei, and thus these fragments remain trapped inside the bomb's uranium pit. Here, their motion is converted into X-ray heat, a process which takes about a millionth of a second. By this time, the material in the core and tamper of the bomb is several meters in diameter and has been converted to plasma at a temperature of tens of millions of degrees. The X-ray energy produces the blast and fire, which are normally the purpose of a nuclear explosion. So again, to wrap everything up, atomic bombs are nuclear weapons that use the energetic output of nuclear fission to produce massive explosions. So I did hope you enjoyed my presentation and my explanation of the type of nuclear chemistry needed for a nuclear bomb to work. It is a very interesting topic, and I hope you enjoyed it.